Hey everyone, Mrs. Herman here. We are going to cover a volume lesson in Bridges today together. So you should have already downloaded your student book, page 234. It says Packing Matt's Marbles, and we are going to get started with working a little more with volume today. So the first thing I need you to know for this, and you don't need to have a copy of this, just go ahead and look at mine, is so if you remember way back to Unit 1, we talked about Brad and his baseball business. And we are bringing Brad back, and he actually has a brother named Matt, and he has a bunch of marbles. And so they are going into business together, and so we need to talk about the boxes that they're going to have to put the baseballs in and the marbles in. So if we look at this, this kind of gives us an idea, and I want you to take a minute to think about, how do you think, so this is the size of a box that one marble fits in, and this is the size of a box that one of the baseballs fits in. And so they're trying to be super efficient with how they're mailing these things out. So I want you to think about, how many of these marble boxes do you think could fit into a baseball box? Go ahead and take a few seconds to think about that. Okay, and I'm going to share with you the actual dimensions. So if you look at this, okay, so here's the marble box. It is a 1-inch cube. So it is a 1 by 1 by 1 for all of its dimensions. The baseball box is a 3-inch by 3-inch by 3-inch cube. So what that tells us, to help make it a little more visual for you, if we take out these blocks, if this represents a marble, this would represent the baseball box, 3 by 3 by 3. So how many marbles could fit inside this baseball box? Yeah, you're gonna do 3 times 3 times 3, and that's gonna give us 27. So every baseball box, if I have this is all 27. You can even kind of picture it if I break this apart into layers. So here's layer 1, it's a 3 by 3, there's 9 marbles. Here's another 9, that's gonna make it 2 layers tall, and this is going to be my third layer. So there's another 9. So 9 times 3 gives me that 27. So this is one baseball box, all right? Now if you are looking at your student book page, so I would recommend split screening this video with your student book page, or having that printed out in front of you so you can follow along with me. We're gonna try and figure out, you're gonna see there are 5 different kind of box dimensions listed. Now those box dimensions are not in inches, which is a little confusing. Those box dimensions are how many of these baseball boxes fit in there. So the first one is a 2 by 6 by 2. What that means is that in that box, and you're gonna kind of see I have this is kind of a replica of what this box would look like. There can be 2 baseball boxes, okay, by 6 wide, you're already envisioning this is a lot, okay? And it's going to be 6 tall. So this is a big visual of what this box is going to hold, and a lot of marbles, and that's meaning all of this is filled in, okay? I just didn't have enough cubes to do that. So if every box holds 27 marbles, how many marbles is this entire box, if this were filled in, would that be? So a 2 by 6 by 6, that represents 2 boxes across by 6 boxes wide by 6 boxes tall, okay? So that's like saying 2 groups of 27 by 6 groups of 27 by 6 groups of 27. So there's a lot of different ways you can do this. One way that I'm going to talk about today is we're going to go ahead and we're going to find the volume in terms of Brad's baseball boxes. So if we were to do 2 times 6 times 6, okay, we know 2 times 6 is 12, and 12 times 6 is going to be what? Yep, 72. So that is not my final answer. That's 72 baseball boxes. Now, how many marbles fit into a box? Okay, 27. So every single one of those 72 boxes has 27 marbles in it. So what do you think I'm gonna do next? Yeah, we're gonna do some multi-digit multiplication here. You can multiply whichever way you prefer, but you're going to be multiplying the 72 boxes times 27. Okay, go ahead and take a minute to do that multiplication, and you're going to type in your answer. And you should end up with an answer of 1,944 marbles. Okay, just in this box. That was for the first question. Let me go ahead and take these down. Now for the second question, it gives you a different box. So that box is going to be a little bit different than the one that Mrs. Herman has in taped on the wall. So the dimensions of the next box for number 2 on your student book page is a 2 by 6 by 12. So for me, I'm always trying to look for the most efficient way that I can solve things. I noticed that is really similar to the first box. It was a 2 by 6 by 6. Now it's a 2 by 6 by 12. I've just doubled one of the dimensions. So what do you think that's going to do to my answer? Yeah, it's going to double my answer. So if my answer before was 1,944, okay, I'm just going to double that last answer. 3,888 marbles is what I'm going to get for number 2. Okay, so that's just double the amount. So that's like taking this box and having another one of those right next to it. Okay, awesome. Next up, we have a 4 by 5 by 3. So we could keep using these. We know it's great to have models in front of us, but we also want to get to be the most efficient we can in math. And so now we're starting to catch on to, okay, there's kind of a formula I can use here. Let me figure out the volume of the baseball boxes, and then I just multiply that by my magic number of 27, and that'll give me my total number of marbles for the box. So let's do that one together. So in number 3, that is a 4 by 5 by 3. So go ahead and tell me what 4 times 5 times 3 would be. Yeah, you're right. 4 times 5 is 20, and 20 times 3 is going to be 60 baseball boxes, and I have to multiply that by what number? 27. So 60 times 27. Go ahead and multiply that out and share the answer that you get. You should end up with 1,620 marbles. So that's definitely less than the one from above. Okay, we got 2 left. Next up is a 2 by 8 by 3. So again, let me erase my answers here. A 2 by 8 by 3. So go ahead and let's find, remember this is for the number of baseball boxes. So 2 times 8 times 3. 2 times 8 is 16. 16 times 3 is going to be 48. So that's how many of Brad's baseball boxes are going to fit into this container. 48 of these. How many marbles is that going to be? So I'm going to multiply 48 again by 27. Go ahead and take some time to multiply that problem. And I'm going to get 1,296 marbles. Awesome job. Okay, we have 1 left. Okay, this one is telling me that there are 4 baseballs in 1 layer. So let me take these off so you guys can kind of visualize this. Okay, so 4 baseballs in 1 layer. All right, 1, 2, 3, 4. So there's layer 1. And I'm going to have 13 of these. I do not have enough blocks for that. It's going to be 13 layers tall. So what are the dimensions of this box going to be? Yeah, it's going to be, okay, if I set it up this way, I could have also set it up this way. So it really depends. If I set it up this way, it would be a 2 by 2 by 13 tall. Or honestly, I could just do them this way, and it would be a 1 by 4 by 13. Would those give me the same answer? Yes, very good. They would. No matter what, I'm going to get 52 baseball boxes when I multiply that. So now I have 52 of these, and I have to figure out how many marbles that's going to be. So I'm going to do 52 times the magic number, you guessed it, 52 times 27. Go ahead and multiply to see if you get the same answer as I do. And you're going to end up with an answer of 1,404 marbles. Okay, awesome job, everybody. So this is the idea of figuring out the volume inside of a larger volume and really using kind of tools to help us visualize it and then move on to a more efficient way or a formula we can use to make things faster for us. So awesome job today, everybody.